Plane in and of itself, the SR-71 proves that we're not on an oblate spheroid that spins. The Lockheed can fly at a max height of Mach 3 and flies at an insanely high altitude. Now, if the Lockheed can go over 2,000 miles an hour, how much curvature should it have to account for to stay at the same altitude? Top speed, again, is 2,200 miles an hour. Let's just say there's 2,200 miles between point A and B. That would be 570 miles of curvature between the 2 points of reference. That'd mean that the Lockheed would have to be dipping 9.5 miles a minute, or 836 feet a second. But let's see what NASA thinks about planes flying over Earth. Derivation and definition of a linear aircraft model. Model of a rigid aircraft of constant mass flying over a flat, non-rotating Earth. It's gotta be the only one, right? It's gotta be the only one. A mathematical model of a CH-53 helicopter. The helicopter equations of motion are given in a body axis with respect to a flat, non-rotating Earth? If this is the first time you're hearing this, then you heard it here first, you know what I'm saying? The sun actually goes around our flat Earth like this, clockwise. It acts as a spotlight shining down onto the flat Earth that we live on. It gets closer and farther away, causing seasons from the North Pole. On its most inner declination around the North Pole, that's when Alaska can see 24 hours. On its most outer declination, that's when the Northern Hemisphere experiences winter. This is the equator. This dark line here going in a circle, that's the equator. Everything north, which is towards the North Pole, and everything south of the equator is the South Hemisphere. This is the Northern Hemisphere. Water, needs a container, dude. And I'll tell you what's containing all of the quadrillions of gallons of water in our ocean. Antarctica. It's actually an ice wall that encompasses us 360 degrees. And there's an Antarctic treaty written and that says the 60th south latitude can't go past there. You'll die. Sea level. Seriously.